Hello, everyone, and welcome to the latest podcast from Gas Pathways, a multimedia communications platform dedicated to innovation and technology in the natural gas industry. My name is Dale Lunan, and I'm the America's editor for Natural Gas World and Gas Pathways. This podcast is looking a little bit more closely at methane mitigation, up close and personal. The Canadian oil and gas sector has been challenged by the federal government to reduce methane emissions by 75% by 2030. Technology exists today to achieve many of the cuts needed to reach that goal. And in today's episode of our Gas Pathways podcast, we'll look at how two companies are getting the job done. Joining me today are Scott Vogt, Technology and Innovation Lead at Tourmaline Oil, which despite its name is Canada's largest natural gas producer, and Connor O'Shea, President of Westgen Technologies, which is deploying technology to replace pneumatic devices powered by compressed natural gas, mainly methane, with devices that instead use air compressed by renewable solar energy. Scott, let's start with you. Tourmaline has quickly become a leader in cleantech, and particularly in cleantech targeted at methane monitoring and mitigation. Tell us a little bit about where methane cleantech is at right now, and perhaps a couple of the major focus areas that Tourmaline is working in.
Yeah, great. Thanks, Dale. So I guess at Tourmaline, when it comes to cleantech, we kind of say we've got four primary pillars, one being methane, one being diesel displacement, water recycling, and energy efficiency. So we'd propose that we're leaders in all those, but for this specific topic, we'll kind of jump into methane mitigation. So we started looking at methane mitigation some time ago. We've replaced all of our high bleed pneumatics with either low bleed pneumatics or zero bleed pneumatics. That made a big impact for us. We've reduced our methane emissions by over 200,000 tons, hitting our methane target 3 years early. But I think what's also really kind of neat or cool is we've partnered up with the Natural Gas Innovation Fund, and we've developed an emissions testing center that's focused on methane emissions. So that testing center is essentially a platform where clean tech companies can come to that center and they can validate their technology. So we're helping develop methane either detection or reduction equipment, and help getting it kind of from point A to point B and using that testing center. So it's a collaboration between the University of Calgary, Tourmaline, and the Natural Gas Innovation Fund that set this testing center up. We've got some lab space for early tech, and then it comes to a Tourmaline site just outside of Edson is where the emissions testing center is at. Maybe we can we'll get into that a little bit more, but that's probably a good starting point.
Okay. Connor, you're working a lot with Tourmaline, and you're also working at the emissions testing center. But you've already commercialized your technology, which I think you refer to as EPOD technology, to replace gas pneumatics with devices that use compressed air. Tell us about that technology, how you managed to commercialize it, and where you're at now in terms of actual installations in North America.
Sure, thanks, Dale. So EPOD stands for Engineered Power on Demand, and it's a solar hybrid remote power generation technology. So if we take a step back, I guess first of all, making sure the audience knows what pneumatic devices are. The best example I like to use is the air gun in a mechanic's garage. You know, that's a pneumatic device that uses compressed air to provide the force and do the work. In oil and gas, historically, all around the world, we've always used pneumatic devices in applications like opening and closing valves and running small pumps, but quite often we don't have compressed air available in the remote locations where this is happening. And so historically we've used the thing that we do have, which is compressed natural gas, because that's what comes out of the wells. And so of course it's that use of the gas in that capacity, and then the gas vents into the atmosphere, and that's what's creating a good wedge of these methane emissions that we're talking about. So I tell that story because, you know, one of the kind of root causes or legacy issues that has resulted in this emission source is the fact that it's actually been really hard to generate reliable power on a remote location, particularly if you want to use the raw fuels that are coming out of the well and not have to truck processed fuel back into the location in order to generate power. So that's the context of why we started the business. We saw, this need where there was a remote power generation gap, and very specifically in that kind of 1 to 50 kilowatt range, there weren't very many solutions available in the market. That just happens to be how much power you need in order to actuate these devices and run these pumps without methane emissions. And so we developed this solar hybrid power generation technology to be able to power an air compressor or power electric actuators and eliminate that source of emissions. By doing that, we reduce emissions by about 99.5%. So that's the context. In terms of how we developed the technology, we really did, we developed a prototype in the, in our garage, so to speak. It actually was the NGIF and the Emission Testing Center, coupled with ERA, Emission Reduction Alberta, and Sustainable Development Technology Canada. That was the platform that we used to really launch this product into market and to commercialize it and de-risk it. So we actually got a grant from those 3 organizations, and within the grant, it allowed us to hire a number of engineers and designers to improve our technology, and then actually deploy the units to 10 different oil and gas producers, including Tourmaline, where we've got some units that were deployed to the emissions testing center. So by doing that, we were able to really refine our technology and make it a robust commercial piece of equipment. So I would say that's been a big enabler. In terms of where we are today, we've now got sales, we've sold over 250 units to more than 45 different oil and gas producers, and these units are now deployed all across North America. So we've been very fortunate that, the timing of, and really the focus that we've had on methane emissions in Canada, the timing of such has been really great because it allowed us to develop a commercial product really before other places in the world were thinking about it. And that's given us a huge opportunity now because we've got this leading product that now all of a sudden the market really needs all over the world.
You mentioned that in the commenting on the technology itself, or the, I guess, the use case of the technology, you mentioned using either pneumatics or electric actuators. Why are you focusing on the pneumatics as opposed to the electric actuators, using that solar energy to power directly the valves and the pumps, etc.? Why was the compressed air option the best one?
What we find is that it depends on the application on whether electric actuation or pneumatic actuation is a better solution. So to level set, most sites always have these pneumatic devices using compressed natural gas. When we're talking about building a brand new site, there's nothing there yet. So we can put a non-emitting device in, and we can either use a pneumatic device with compressed air, or we can just use a brand new electric device. When we're talking about going back to existing sites and retrofitting them, we see a big advantage to sticking with pneumatic because you don't actually have to change the devices.
Yeah, it's already there.
The same devices stay exactly where they were. They function the exact same. All we do is we switch the input source from compressed natural gas to compressed air, and then you eliminate that emission source. So in particular on larger sites, in a retrofit application, we think that compressed air makes a lot more sense because you don't have to replace all the devices. On single well pads and smaller sites, sometimes we see electric actuation being more attractive economically.
Scott, Westgen is an example of the innovation that's taking place in the natural gas sector, and I know it's a big thing for Mike Rose, your CEO. It's a big thing for the Natural Gas Innovation Fund and the Canadian Gas Association, which launched the launched NGIF a few years ago. What's driving this innovation? Is it regulation based? Is the market looking for innovative solutions? Where is all this coming from?
I'd say it's a little bit of everything. So the Natural Gas Innovation Fund started up by industry essentially. So you had the Canadian Gas Association started up, and it's industry putting in their own funding, granting to organizations in order to get them up and started in the clean tech world that's designed for natural gas. So that would be just an industry initiative that's really driving change and looking for that innovation. On the methane space, you started to get when Canada set the original 45% methane reduction target, and there were regulations that came along with it. That was definitely something that started us down a trend. So I would say that one of the craziest things about that set of regulation is that technology really didn't exist to achieve that regulation, and I'd propose that's one of the first times in history where it hasn't been that an industry is regulated to switch to a different device that's already existing. All these things really needed to be finalized and scaled. So you kind of saw a time frame where you needed this huge amount of technology and innovation and this huge amount of work going into that ecospace. So like overnight, we went from very little things of methane to all of a sudden we've got Canadian satellites in space. We've got aircraft that can find a barbecue that's not lit. We've got continuous monitors that can measure to the parts per billion. And we've got all sorts of technology now that it's capable of zero emission well sites and zero emission pneumatics. So that took a huge amount of effort. And I wouldn't say it was the regulation that necessarily did it. It wasn't the regulation kicked it off, but it was these programs such as TIER in Alberta that really gave the funding and the ecospace for all these innovation to happen. So for people that don't, the TIER program is a program in Alberta that takes carbon taxes that industry pays, essentially uses those carbon taxes in order to fund, so the government doesn't take any of the money. They use the carbon taxes to fund both granting organizations such as the ERA that would have where Connor would have gotten his grants, and offset programs and emissions performance credits. And those systems really allowed us to have a value proposition to really act early and to really put money and efforts into this type of innovation and allowing Canada to move one step further. So those, yeah, they were definitely policy, but I would say it was productive policy out of Alberta's TIER program that really helped drive the change, not the restrictive regulation necessarily that made the change happen, but it couldn't have happened without the productive policy that was giving that carrot or that ability for this technology to really move. Because again, this tech didn't exist at this scale to even go implement at that point in time. Mm-hmm. So I guess as we move along and we move now from 45% to 75%, I propose we've got to take the learnings that we've had from how we can use a productive policy like the TIER program that can encourage tech and innovation and give additionality to Canadian oil and gas to show that we are the cleanest gas in the world and that we maintain this additionality as we move forward. So as a policy kind of gets defined, I think it's important that those things be considered in the policy themselves. Just really look at what drove the tech in the first place, and we've done incredible at it. So let's keep the things that are going well.
As the technology is introduced and commercialized, a lot of talk surrounds the energy transition. A lot of people in the industry don't like to look at it as a transition because that implies a beginning point and an end point. They like to think of it more as an energy evolution. Hydrocarbons, I think most people agree, are going to be still relevant to 2050 and quite likely and beyond. Connor, can you talk about how Westgen is addressing the evolution, and are there any other technologies that you're working on to advance it?
Yeah, for sure. Thanks, Dale. I really appreciate that you called it the energy evolution, because that's what we've been calling it, and we're trying to get that to catch on. So let's keep saying it. Um, I mean, at Westgen, our purpose is to empower the energy evolution, and we use the word empower because we're a bunch of dads, so we had to use a pun and make a power generation joke. But in all seriousness, we think that energy transition is a bit of a misnomer because that kind of implies that we have one source of energy today and we're moving to a different source tomorrow. And that's actually just not reflective of what's happening. So we think evolution is a better word. And evolution really means, we've got a certain energy mix today. Within the mix, each wedge has its own characteristics, and both the mix and the characteristics of the component parts are evolving over time to something different. And that evolution is driven by society's needs and demands. And that's actually how it's always happened, right? So when the biggest priority is energy security or reliable energy or low cost energy, those have always been the problems that our industry has been really focused on solving. And we've done absolutely incredible things in the 150-year history of this industry. Take the shale gas revolution as example of what this industry was able to innovate and do when energy security was the biggest concern of society. And so I would say that in the last 3 or 4 years, it's been very clear that society is demanding cleaner energy, and that is the challenge that I see our industry stepping up to achieve right now. So I see this evolution happening, and I think the amount of progress that we're making towards it is tremendous. And Westgen is just one little example, but the programs that Scott mentioned are enabling this evolution. And I like Scott, am really happy with the way that Canada and Alberta and our regulatory bodies here have approached these changes and created this productive policy, as Scott called it, because it has enabled a significant amount of progress on these challenges, but also a significant amount of economic activity. And this technology that we're developing here, because we've done it ahead of the rest of the world here in Canada, we're creating these tremendous opportunities to export these solutions to the rest of the world and bring more prosperity to our community here. So I think there's a lot of great things happening. In terms of what else Westgen is doing, yes, we're not stopping, where we are on pneumatics. Pneumatics was the first thing that we addressed because it's one of the biggest wedges in the pie of methane emissions, and we would say it's the lowest hanging fruit. But honestly, our industry is maybe only 5 years away from completely eliminating this problem. And then, so we're at Westgen, we're saying, okay, what's the next lowest hanging fruit? Because we know that it doesn't stop when we get this done. It's a process of continuous improvement and continuous growth. So we continue to work on new solutions.
Something just occurred to me while you were talking about that. The current EPOD technology is deployed primarily at well sites. Is it adaptable elsewhere along the gas value chain at say at pipeline compressors or at even at the utility level? Is it adaptable? Because that's a big thing. Critics of the industry say, natural gas can never be considered clean because it leaks methane from the minute it, from the time it's fracked to the time it's burned in your stove at home.
So that's a great question, Dale. And the answer is absolutely. The same technology applies all the way through the value stream, right from the wellhead where you're the well site where the gas comes out, all the way to the local distribution company where they've got, compressor stations and pipeline riser sites that have pneumatic devices on them, and we can fix all of those problems. One thing I would say to those critics is that yes, there are a lot of methane emissions in the system today, and that's really a reflection of what the priorities of, this society going back into the past have been, where nobody's ever said, I want to pay more for my gas to have a cleaner product until recently.
Mm-hmm.
And now we're seeing things like responsibly sourced gas. And what's happening is these problems are getting cleaned up, and people are paying a bit of a premium for gas that comes from a system that doesn't have these leaks, because in my mind, a lot of these leaks and these intentional events, it's not a foundational technology problem, at least not anymore. It's not that we need to have a new breakthrough in physics to be able to figure out how to eliminate these emissions. It's actually a commercial and an economic challenge. We need to find cost-effective ways to do it. We have the technology to do it. We can get rid of the leaks. There's lots of, if you look at sour gas as an example, we don't let sour gas leak because it's too dangerous. So we've always found ways to make sure that doesn't leak. We can do the same. It's just, are people willing to pay for the incremental cost that adds, and or are there ways to create productive policy that allows our industry to build, to put the engineering work into developing cost-effective and scalable solutions.
Scott, you're something of a policy wonk. We've got this technology. We've got some momentum behind it. What is needed to continue that momentum, and what's holding back Canadian technology providers, especially from getting this out to every gas producer in the world, really?
Right. I might take one step back too as well, because you kind of mentioned the idea that the leaks and things like that natural gas could never be clean. And I think you really need to look at jurisdictions when making those statements. Like, Canada's had natural gas conservation laws. Well, Alberta's had natural gas conservation laws. That's actually what our original regulator was about, was conserving the resource and making sure that you weren't just producing oil. Yeah, you weren't producing oil and letting the gas leak off. So for years and years, we've been putting things in place in order to be able to produce both oil and gas in Western Canada. And that's kind of what really differentiates some of the regulations and why we're cleaner. Because if that natural gas is obviously the product we want to sell, there's no financial benefit to have it leaking off into the air. Mm-hmm. So other jurisdictions where they don't have the pipeline infrastructure, the natural gas piping available, natural gas will become more of a nuisance, and then that's where you do get some of those numbers that are quite high as far as how much gas is being released, or those types of things. But I propose the natural gas in Canada, especially through Alberta and BC, is incredibly clean, and there aren't a lot of leaks, and that conservation of gas is already happening, and we're doing more and more and more. Now, can we always get better? Absolutely. So to kind of get to the next piece about the policy, I would say the policies that allow us to really take advantage of the Canadian system, like, we have some very significant advantages. So again, if I was going to compare a Tourmaline average to like a US average as far as a life cycle intensity or a methane performance, we're orders of magnitude better than the US average. And that would be similar for many companies in Canada. So I propose we got to really come up with ways to take advantage of that and use these systems, whether they be responsibly sourced gas or methane performance credits or the offset systems or voluntary offset systems. We want Canada to be able to take advantage of the fact that we're producing a much cleaner molecule than anywhere else in the world, and that we should go look for a premium and look for a social license to expand our production of natural gas in Canada and displace higher carbon fuels around the world. That is really the Canadian advantage, is to have the Canadian taxpayers get a benefit from the resource that they own by selling a cleaner, nicer, better product that people want to pay a premium for. So when we build out policy, we just need to kind of keep that in mind, that the worst thing you'd ever want is for the US to be able to sell responsibly sourced gas being an order of magnitude higher emissions, because we don't have that additionality because we're regulated to do so. So you can't actually sell a responsibly sourced product here because there's a hard, fast regulation. I propose the regulation should be encouraging regulation like the tier program in Alberta that's really makes it so that there's a value proposition to be the cleanest gas, and then we can sell our gas as the cleanest gas and maintain that value proposition for Canadians the whole way through the sector.
Okay, and the $64,000 question, is that happening?
Absolutely. So I've never seen in the history of really anything have I seen tech and innovation move at a faster pace than what's been happening out of the tier program. You've got all of a sudden you've got like engineers doing engineering work again, and you've got just some of the like biggest and craziest ideas coming out there every day, and now we've got a system in place. So I'd say absolutely it's happening. We should really look at where it's happening well and double down on those pieces of policy and be very cautious to put in policy that can stop it, because it's very easy to put in a restrictive regulation and the whole additionality blows up, and the systems that are encouraging all this innovation could end overnight. But it's working incredible. I'd say we double down on the things that are working great and continue to evolve, as Connor said. And I do love the word evolve instead of transition. Let us evolve and get more value for what Canada's doing right today.
Hey, Connor, any final thoughts?
I think I'd reiterate some of the things that have already been said, but just to, to sum it up, I think we have a really tremendous economic opportunity for our community here by continuing to incentivize innovation, incentivize better performance, and the outcome of that is we create a whole bunch of jobs. The talented people who know our industry well, they get deployed, and their brain power goes into solving this global problem, and then these solutions get exported to the rest of the world, where we create more economic opportunities. But not only that, I think if we continue on this path, as Scott mentioned, ultimately, this creates a brand of Canada as a clean energy leader. And that brand, it not only, like I mentioned, creates the economic opportunity around the technology, but it also continues to enable our resource industry to provide the energy that the world needs. And by creating that brand, I think we enable our industry to have the license to export our energy to other parts of the world, and again, support the challenges that our world faces of both climate change, but also energy security and energy poverty.
Excellent, which is top of mind everywhere in the world these days. Thanks, Connor. Thanks, Scott, for taking time out of your busy Monday morning to talk with me here today. And thank you, everyone, for signing in to this latest podcast from Gas Pathways. Please keep an eye out at gaspathways.com for future podcast sessions, and we look forward to joining you again in the near future. Thank you, and have a good day.